10 reasons colonizing Mars is a bad idea. You will never guess what the number 1 reason is. Like and subscribe for weekly videos. In the comments below, list one topic you think should be in a top 10 video and comment if you subscribe to this channel. Although SpaceX President Elon Musk has big plans for settling the red planet, boasting of big rockets, nuclear explosions, and an expansive system capable of transporting hundreds of thousands of people off the world, he may have to rethink those plans. Key figures at NASA, such as Wernher von Braun, have also championed Mars as a next logical step in humanity's conquest of the stars, but recent research and discovery suggest that attempting to settle Mars may not be such a great idea after all. From dangerous Martian regolith, low gravity, and harmful cosmic radiation, Mars seems like the worst environment for human life in the solar system. 10. There may be life beneath the Martian surface. With the discovery of liquid water on Mars, scientists are eager to see what else lies beneath the surface. NASA has long stated that we need only to follow the water in order to find extraterrestrial life, based on the fact that where there's liquid water on Earth, there is also life. Through the last 20 years, we've sent dozens of probes to the Red Planet, and have discovered significant subterranean sources of water as well as occasional water on the surface. It's clear that there is water beneath the surface of Mars, and scientists think that it's only a matter of time before we find life. Recent research suggests that Mars has a similar subterranean network of microbial life to Earth, dubbed the deep biosphere, and life may not have ever attempted to evolve on the Martian surface at all, suggesting that we humans have an inherent bias when imagining where life can or cannot evolve beyond the safety of Earth. If settlers were to go to Mars, it would be nearly impossible for them to not have an impact on that life, and this would be a violation of planetary protection rules currently in place. 9. Terraforming Mars may be impossible. Science fiction filmmakers and novelists have been in love with the idea of transforming Mars into an Earth-like paradise for decades. In 2018, Elon Musk touted the possibility of terraforming Mars by detonating nuclear warheads over its icy polar regions, which are composed of frozen carbon dioxide. The result, Musk hoped, would allow the red planet to warm, thanks to a healthy amount of carbon dioxide in the atmosphere. But recent research suggests that terraforming Mars might be impossible. While it is undoubtedly true that carbon dioxide is present in the Martian atmosphere, soil, and in its polar ice, there simply isn't enough of it to allow for the runaway greenhouse effect Musk hopes for. Bruce Jakosky and his partner, Christopher Edwards, an assistant professor of planetary science at Northern Arizona University in Flagstaff, found an estimate for the total amount of carbon dioxide on Mars by interpreting data from probes sent to the planet over the course of the last 2 decades. Together, they concluded that while the polar regions of the planet contain the most readily accessible supply of carbon dioxide, melting them, such as with Musk's proposed method of nuclear detonation, wouldn't yield enough to terraform Mars. The team also concluded that strip mining and other means of accessing carbon dioxide in Martian soil would be unfeasible, suggesting that we may be forced to accept the reality that Mars will forever remain an alien and inhospitable world for us. 8. No magnetosphere here on Earth. The magnetic field is essential to keeping our atmosphere safe from the solar wind and keeping harmful cosmic rays from bombarding the surface. Even if someone like Elon Musk was successful in creating a sufficiently thick atmosphere on Mars, without a magnetosphere, it would be stripped away by the solar wind. Some scientists have proposed creating an artificial magnetic field at the L1 Lagrange point, where a potential satellite producing the magnetic field would be at gravitational equilibrium with the Sun's, meaning that it would always stay between the Sun and Mars, but this technology is far beyond our current capabilities. Even those who have proposed it have labeled it as fanciful, citing that many advances in plasma physics would have to happen before it could become a reality. 7. Negative effects of low Martian gravity on humans. For the past few billion years, life has evolved from within an unchanging gravitational field, and to venture beyond that field produces challenges unthought of by those that first dreamed of men living on other planets. The human body is constantly working against the pull of gravity. This force shaped our musculature, and without it, our muscles would atrophy. Experiments on mice in low-gravity environments showed that muscle groups in the legs atrophied within 9 days. Much like our muscles, Our skeletal structure is impacted by the lack of a gravitational field equal to the Earth's. We tend to not think of our skeleton, thinking it to be static, but at the microscopic level it is a complex and diverse system. Without the force of Earth's gravity being exerted on it, human bones develop what's known as spaceflight-induced osteoporosis. Because almost 100% of the body's calcium stores are in the skeletal system, as our bones waste away, that calcium finds its way into the human cardiovascular system, causing problems ranging from constipation, renal stones, to psychotic bouts with depression. The problems don't stop there. It turns out the human heart is heavily dependent on gravity. It's a muscle, after all, and long exposures to zero-G environments causes the heart to become deconditioned to the work it typically has to perform under natural conditions. The organs of the inner ear are also adversely affected, causing humans forced to live in zero-G for too long to feel constantly in distress and out of balance. And there are more, less severe problems which can occur, ranging from falling red blood cell counts, compromised immunity, slower healing, and sleep deprivation. And though there is some research into supplements which may be able to help Martian settlers maintain healthy muscles, more research would have to be conducted, not to mention the fact of the other ill effects slow gravity seems to have on the human system. 6 harmful radiation. A study published in the Journal of Science in May of 2013 measured the radiation that a crew would be exposed to during a 360-day trip, though most estimates suggest 6 months for a one-way trip if launched at the right time. The total amount of radiation was measured at 662 +/108 millisieverts, MSV. The study showed that up to 95% of this radiation would be from galactic cosmic rays, a type of radiation which is extremely difficult to shield against. Though, for a 210-day trip, the amount of radiation astronauts would be exposed to would still be below the career limit established by NASA. The Martian surface is totally exposed to the solar wind and cosmic rays thanks to its lack of a magnetic field. The surface is bombarded by levels of radiation 2.5 times greater than the Earth and occasionally is blasted by one of the Sun's coronal mass ejections. For a bit of perspective on CMEs, the Carrington event in 1859 was the largest geomagnetic storm on record. It caused brilliant aurora displays around the world and wreaked havoc on the telegraph system. But without a magnetic field, this event would have been much worse. Humans in developed nations experience a total of 0.62 rads per year. According to certain studies, the human body can withstand up to 200 rads without sustaining life-threatening damage. Extended exposure to the levels of radiation detected on Mars would lead to a multitude of health problems including cancer, genetic damage, and a gruesome radiation sickness-fueled demise. A Mars colony would have to build their habitats beneath the surface in order to receive the same level of protection from cosmic rays and solar radiation as someone who lives on the surface of the Earth does. But the problems don't stop there. 5. Waterlocked. Though we've discovered countless signs of liquid water being on Mars, most of it is locked away in its rocks and rolling crimson sand dunes. We don't yet have the technology to extract this water, although NASA hosts an ice challenge every year in the hopes that some bright engineering student will crack this particular puzzle. Okay. So, what if we solve this problem in the future? Could settlers drink the water mined from subterranean glaciers or the soil on Mars? No. Not right away anyway. The water on Mars is filled with toxic minerals and has far more salt in it than even ocean water does on Earth. These salts are called perchlorates, and they're highly toxic to us. So toxic, several states in the US have legal limits for perchlorates in their drinking water. Though reverse osmosis may be a potential solution to this problem, it remains to be seen how effective this process would be in removing toxic minerals from water mined on Mars. 4. Supplying Mars colonists. The launch window to get a craft to Mars within a 6-month time frame happens every 27 months. That means that resupply for any settlers on Mars would have to depend entirely on that window. That also means that cargo ships taking supplies to Mars would have to have enough supplies to last them 27 months, unless NASA or any of the other private space exploration companies are willing to bear the cost of a longer travel period. The problem with this is that with our current technology, most spacecraft require 95% of their weight to be fuel. Supplying on a global scale may be challenging, but it's nothing compared to the logistics of trying to supply a planet which is 1.5 astronomical units away from the Sun. And then you have to think about the possibility of something going wrong with one of those supply ships. NASA deals with equipment failures on probes and spacecraft all the time. It's part of the job, but space is dangerous, as eloquently stated by the Martian writer Andy Weir, and a catastrophic failure is entirely possible. Whether the craft is destroyed by micrometeorites, gets fried by a CME, or one of the engines fails, such a catastrophic failure would leave our settlers high and dry for 27 months. Not to mention that such resupply missions would be extremely expensive. If we take the previous entry's comments on the water situation on Mars, things get worse, because if the water obtained from mining Martian soil isn't potable, and there's no way to purify it, then the options remaining are A. Resupply with regular shipments, and B. Recycling urine like the astronauts on the ISS do. 3. Air supply. The primary method for generating air on the ISS is water electrolysis, a process which uses the power of the station's solar cells to split water into oxygen and hydrogen. Great. Problem solved, right? Well, as previous sources have described, not so much. Because of the difficulties with producing technologies capable of both mining water from Martian soil and ice, or purifying it, generating air naturally on Mars through electrolysis may be more difficult than it is on the ISS. The International Space Station is close to Earth, and even though astronauts recycle their fluids as much as possible, they still need to be occasionally resupplied. This would mean that we would have to get enough water to Mars to allow settlers to both safely consume and to allow for the generation of breathable air, and that's simply no easy feat to accomplish, given how heavy water is as a payload. 2. Martian regolith. The soil on Mars is a lot like the moon dust encountered by the Apollo program astronauts. It's a coarse, fine material that easily carries an electrostatic charge, causing it to stick to pretty much everything. On the moon, this caused all kinds of problems. Lunar regolith got into instruments, vents, and even wore down the protective materials of the astronauts' suits. Before we can even begin to think about settling Mars, we would first have to figure out a method for dealing with regolith. Now, this problem might seem small, but studies done on regolith have shown that inhaling this stuff can cause problems with the human respiratory system, and the regolith on Mars has harmful perchlorates in it that can make us sick. 1. Psychological problems. Settlers on Mars will be forced to endure isolation on a magnitude which is impossible on Earth. Sure, you can get stranded in certain parts of the Earth, but home isn't an entire world away, and the Earth isn't actively trying to kill you. Well, not as badly as Mars would be. Extensive research into the psychological effects of prolonged isolation have suggested that Martian settlers would encounter at least 4 different psychological challenges, and that those challenges, when combined, would be a ticking time bomb. To start, colonists would be unable to interact physically with anyone besides their own colleagues, with long-distance transmissions to Earth taking at least 10 minutes, making conversations more than a little difficult, and this would undoubtedly lead to mental illness in some of those permanently stationed on the Red Planet. Prolonged isolation has been shown to lead to depression, insomnia, anxiety, fatigue, boredom, and emotional instability. Even the most well-trained astronauts still suffer side effects from prolonged isolation. Life on Mars means that colonists will have to live indoors. They will never again feel what it's like to see a sunset without a layer of glass and a suit as protection from the Martian elements. Long-term confinement comes with its own laundry list of problems as well, such as cognitive impairment and a bunch of psychological issues from the previous list. The loss of privacy that these colonists would face could lead to stress, fatigue, depression, and anxiety. All told, it's a heavy burden to ask potential settlers to endure.